Hi there guys, back with another video. Although in today's video we are addressing the logarithm rules. Alright, so this is usually taught in grade 12, but I have seen some schools bring it in grade 11 already. Okay, so the first thing that we need to understand is what is exponential form and how can I then go from exponential to logarithms? Okay, so if we have a look-see at the example that I've written down, I've stated that 2 to the power of 4 is equal to 16. So if we have a look, that 2 is our base. The 4 is the exponential value, so that's our exponent. And 16 is actually the value. So I refer to it as our leftovers. You'll see now why. That's not its mathematical term, that's why it's in quotation marks. But it is just the overall value, okay, of what that expression would have been equal to if it was an equation. Okay, now I've asked to state the above as a logarithm. So put it from exponential form into log form. So what you have to remember when you do this is that there's this one saying that I always use is that your base stays the same. All right. And your exponent goes alone. So if you remember this rule here, you will be okay when it comes to logarithms, okay? But that's just changing it from exponential form to log form. You still need to learn the rules in order to simplify it further, okay? So now we're just going to change it. So as I stated, we want to change it to log form. The base stays the same. Okay, and what did I say we do to the exponent? The exponent goes alone, so it goes on the other side of the equal sign. And whatever is left over, that is what you then put into your brackets. So to change it from exponential form into log form, you state that the base remains the same. So the base in this case was 2. The exponent goes alone, so it goes on the other side of the equal sign. And whatever's left over goes into the brackets. Okay, awesome. Now let's get into the rules because this is a little bit more trickier. So for the first one that's stated, it said that we have log with a base, x multiplied by y. Now, when we're multiplying within brackets, if we had to separate them into their own logs, the base needs to remain the same. You can't now change it if I stated here that that was a base 2. You can't make that one 2 and make this one 5 because you feel like it, okay? The base has to stay the same. So you would say that it would change into log, whatever the base is, x, plus log, whatever the base is, y. So when we are multiplying, we are going to add when we separate them into their own logs. And remember, these rules can be vice versa, that you could have been provided with what was on the right-hand side and asked to simplify it that way, or you were provided with what's on the left-hand side and had to simplify it or expand it out into what was on the right-hand side in order to simplify your answer further with other provided information. Okay, so for example, if I gave you log 2 4 times a, that would have changed into log. The base stays the same for both of them. All right, and then each individual one will go into their own little bracket. So it'd become log base 2 with 4 plus log base 2 with a. Okay, and now if I was multiplying and that would land up with me adding, what do you think would happen if we have division and it's the inverse? So we are then going to have to subtract. So in that case, using the same example, we would state that it is log 2, but now it's 4 divided by a. What is really important is that if you look at the example, the numerator is what comes first. Then you have the denominator, and that is what is going to be subtracted from that numerator's log. So always ensure that it's top minus bottom. So you would then state that it is the log. The base stays the same of 4. minus the log, the base stays the same, of a. Yes, in these examples, you can simplify further with the log 2, 4, but because I'm doing one rule at a time, I'm therefore not simplifying, I'm just explaining the rule. So please, if you think I could go further, you are correct, but we are just doing this by rule concept. Okay, now for the next one. What do we do when I have an exponent within my brackets? Okay, what you would then do is you would have to remove that exponent, but you can't just get rid of it. So you're then going to multiply the log by that exponential value. So if I gave you log 2, 4 to the power of 3, you would take that 3 to the front and multiply the log by that value. Okay, I do hope this does make sense. Just be very careful that exponential value does disappear from here, and you would then place it in front. Okay, please don't rewrite it with the 3 still existing within your brackets. You have now moved that exponent to the front to be multiplied. All right. Okay, then your next rule, and I know it seems like it's never ending, it's just because it's new concept work, but once you get into the groove of things, this actually becomes really simple. All right, so if we have to have a look-see, it says log, we have our base, but our number is also the same as our base. In those circumstances, no matter what it is, your answer will always be 1. So if I had log 10, 10, my answer would be 1. If I had log 2, answer 2, it would then be 1. So no matter what it is, if your base and the number are the same value, your answer will always be 1. Okay. Now, what happens if I have 0 in the brackets? That's the next rule. If you have 0 in the brackets, your answer will always be undefined. Okay. So no matter what your base is, like I said, I could give you log 2, 0. Your answer will always return undefined. All right. Then we move on to the next one. No matter what your base is, if your answer is 1 in your brackets, the final answer will always be 0. So if I have log, for instance, log 2, 1, your answer is always 0. So the last ones on this page are really just those that it doesn't matter what the base is, if those specific values are provided, you'd either have undefined 0 or 1. And the ones on page 1 are just rules as to how you can manipulate it in order to make the sum easier or to simplify it. Okay, so I've just split it into those 2 separate pages. All right, so let's just go over the rules one more time. The first rule, if I am multiplying, it means I would be adding them in their separate logarithms. If I was dividing, I would then be subtracting. And what I need to remember is I'm taking the one on top in the numerator, subtracting the one in the denominator. Then your next rule, if you have an exponent, you would bring it to the front and you'd multiply by that exponent. And remember, it needs to be then removed from where its position used to be because you're almost rehoming it and putting it in front now. Okay. Then the rules that no matter what your base is, they will always return such an answer. If your base and your number are the same, you will always get an answer of 1. But if your number is 0, no matter what your base is, your answer is always undefined. And then the final rule for today is that no matter what your base is, if your number is 1, your answer will always have been returned as 0. Okay. And then the one thing that you just need to take into consideration is that we never have negative bases. So if you get a negative base, you will see in your calculator, it will give you a math error. So then just know that you might want to revise all your steps and see, is there perhaps a place that you have gone wrong? Okay. So I do hope that these rules have been made simpler for you, that they've all on one little YouTube video. So please do like and subscribe if you'd like to see any new content, and I will be doing more examples and exercises on logarithms moving forward. All right. I look forward to seeing you guys again. and you must all have a blessed day.